focus on coordinate geometry. And our main topic is relations, functions, and graphs. All right, so if you're given 2 points on a straight line, all right, so if you have a straight line or a line segment, that's a better word. That's a way of a line segment like that. All right, and on that line segment we have points A and B. So A and B are 2 points that lie on a line segment. To find the gradient, now remember we said that gradient is the measure of how steep a line is. All right, and we normally find a gradient from a graph when we calculate a set of ordered pairs, plot those ordered pairs, and then we construct a right angle triangle, then use the formula gradient equal rise over run. But in this question here, we're not given any ordered pairs, nor a function to work with. All we're given is 2 points. So we can use a series of formulas to find the gradient, the length, the midpoint, and even the equation of the line. All right, so we're going to look at how to find the gradient. All right, I remember I said that the gradient can either be positive or negative. If it's positive, it will be falling to the right, like this one, and if the gradient is negative, it will be falling to the left. All right, so the gradient is this formula here. Now you notice if you look at the points A and B, A have one x value and B have another x value. So we have 2 x values, x1, x2. And also for the y, we have 2 y values. So what we do, we just find the difference of those 2 y values and the difference of those 2 x values. And that will give us the gradient. The length is basically squaring the difference of the x and the y coordinates and adding them. Then you find the square root of that. It's technically Pythagoras theorem if you look at it. All right. And you know, just mention you that the gradient of a straight line is actually finding the tangent or tan theta of a line. All right, now the other one is a midpoint, which is the middle of the line. So the middle of the line will be there, and simply put, all you need to do is just add the 2 x values divided by 2, add the 2 y values and divide it by 2. So notice that gradient, we use common letter M for gradient and capital letter M for midpoint. Okay, last but not least, how to find the equation of a line segment. Now, all equations must look like this. Y equal mx plus c. All right. Now, as you study further, there are going to be other representation you can actually look at. But for CXC purposes, this is generally what they recommend. Y equals mx plus c for CSEC purposes. You know. All right. Because in CAPE, there's another way of writing it. All right. So what we do is that we choose a point. So we have 2 points, A and we have B. What we do? Choose 1 point. Now, in this example here, I chose A. Now, after you choose a point A, what you're going to do, we're going to use the gradient formula. It's actually the gradient formula you actually use to find the equation. So we're going to say Y subtract, just like the y2 subtract y1. So it's y subtract the y value. Now this y value is the y value of the point you choose. Divided by, notice the gradient formula, divided by x subtract the x value of the point we choose, which is x1. And that's going to equal to the gradient. And what we do next is that we're going to make y the subject of the formula and get it looking like y equals mx plus c. Okay, let's look at an example. All right, so we're given these 2 points here. So just imagine we have a line segment and we have P and we have Q on that line segment. So we're gonna call -1 x1. We're gonna call 3 y1. We're gonna call -3 x2, and we're gonna call 5 y2. Sometimes we get mixed up labeling these values here. A common error is to mix up the x and the y and the y and the x. Sometimes some person put x1, x2. All right. So we're going to use the gradient formula, which is m equals y2 subtract y1 all over x2 subtract x1. Now y2 is 5. It's 5 subtract y1, which is what? 3 all over x2, which is -3 subtract x1, which is -1. All right, now 3 from 5, we know it's 2. But right here, so let me go over to this part of the screen. We have -3 subtract 1. Now guys, when signs are together, what do? We use the rules of multiplication. Now 2 negative will give us a positive. So end up with -3 plus 1. So you owe Mr. Brown $3, you go shop with $1, you're gonna owe Mr. Brown 2. So the denominator here is gonna be -2. And we're gonna get -1 for our answer. So the gradient here is -1. So because it has a negative value, the line would be falling to the left. So it's contrary to what I draw on the screen. All right, so moving on. Let's look at part 2. Part 2 says to find the length of PQ. So we're going to use the length formula. And I'm writing it down right here. All right. So y2 is still 5. Oh, by the way, remember, you can actually write x2 minus x1 and y2. It doesn't matter which one you want to write first, yeah? So y2 minus y1, that's going to be 5 subtract 3 square. Remember the plus. x2 is -3 subtract 1 square. So that's going to be 2 square, and we worked out this a while ago. That's going to be -2 square. All right, so 2 square we know is 4. Negative 2 square is also 4, positive 4. And we know that 4 plus 4 is 8. And that the square root of 8 to 2 decimal place, that's going to be 2.83 square units. All right, so let me write it over here. So the answer is 2.83 square units. So that's the answer for part 2. Let's go down to the middle of the line. Part 3. Part 3 says to calculate the midpoint, represented by capital letter M. Now, it doesn't have to be M, you know. They could actually tell you that the midpoint of a line segment PQ is X. So, you know, it doesn't have to be M. And we're simply going to add the X values. Oops. That's X2. Now you notice that this answer here looks like a coordinate when you finish work with it. So it's Y1 plus Y2. A common mistake, you see, is to put a subtraction sign right here. So not sure why, because you know that to find the gradient and the length, we always find the difference of the X coordinates, and the midpoint is plus. So that could be a reason why students put a minus sign right with the pluses. All right, so X1 is -1 plus -3 divided by 2. And Y1 is what? 3 plus Y2, which is 5, divided by 2. All right, so when signs are together, we use the rules of multiplication. So right here, so let me, so we can bring it over here. So a positive and a negative will give you a negative. So we have -1, -3. On your O, on your O. So your O 4. So the numerator for that that thing is going to be -4 divided by 2. And that's going to be 8 over 2. All right. So 3 plus 5 will give you 8. And then when we reduce this, we're going to get -2 and +4. So, ladies and gentlemen, the midpoint is -2 and 4. All right, let's look at the last part, part 4. Part 4 says to determine the equation of the line segment PQ. All right. So remember I said that in the first slide, the first thing you're going to do is to choose a point. So I'm going to choose point P. Now, if you choose point Q, you must end up with the same answer. So I'm going to choose point P, and P is -1 and 3. And then we're going to use the formula. And if you remember, or if you recall, we said that it's actually the gradient formula. So it's Y, subtract the Y value of the point you choose. So that's going to be 3. If I've chosen Q, it will be Y subtract 5 all over X subtract the x value of the point we choose, which is 1, and put that equal to the gradient, and the gradient was negative 1. And what I'm going to do, I'm just going to put a 1 for the denominator, all right, just to make it look like a fraction. And guys, what you notice, two negatives, when two signs are together, what do? We use the rules of multiplication. So 2 negative will give us a positive. So the next step is that we're gonna make y the subject of the formula, or we're gonna have to write it in the form of y equals mx plus c. So this is a fractional equations, and to solve fractional equations, we're gonna cross multiply. So we want to find y, so it's best to multiply diagonally with the y first. So it's gonna be 1. So it's this one here, that one, multiplied by y subtract 3. All right, so it's 1 times the entire thing, right? Now, let us say this was like a number, say 5 for the denominator. What some students will probably do is just to multiply 5 times the y and forget about the 3, but that is incorrect. Hence, the reason why I use these brackets here. All right, so we'll just multiply the leading diagonal. So we're going to multiply the other diagonal. So it's negative 1, and we're talking about this negative 1 here. Multiply by the denominator here, which is x plus 1. So we're going to use distributive law. So 1 times anything will give us the same thing. So negative 1 times x gives us negative 1x. All right, now you don't have to write a negative 1. You could actually write negative x. And negative 1 times positive 1 will give us negative 1. Now we need y equals mx plus c. So we don't need this negative 3 here. So what I'm going to do, I'm going to add 3 on the left and also on the right. So I'm going to have y subtract 3 plus 3 equals negative 1x. Subtract 1 plus 3. So negative 3 plus 3 will give us 0. All right, so let me make some space for here. All right, so, well, this will go away, not true? So we end up with y equal negative 1x. Now negative 1 plus 3. We're going to start borrowing $1. And you're going to shop with $3. Pay off your debt, you're going to have some change. You have $2 change. So this would have been your answer. As you can see, it is in the form we call y equals m. This is our m. This is our x, and this is our c. And you guys remember that c represents our y intercept. All right, so moving on to our next slide. All right, so we have two types of line. We have what we call parallel lines and perpendicular lines. Two lines are parallel if they have the same gradients. So each line have their own gradient. Now, if two lines have the same gradient, it just means that they are parallel. So hence, M1 equals M2. Pretty straightforward. Perpendicular lines. Now, perpendicular means right angles. So when you have two lines that meet at right angles, they are perpendicular. Now, if you multiply their gradients and you get -1, then the two lines are perpendicular. Let me say that again. Two lines are perpendicular if you multiply the two gradients and you get -1. All right? So M1 times M2 will give you -1. So you might say, sir, what if you want to multiply the two gradients? You don't get -1. Suppose you get -5 or -4. Well, they're not perpendicular, but they intersect at each other. So you could say they're neither parallel nor perpendicular. All right, so let's look at this question here. All right, so it says state if the following pair of lines are either parallel, perpendicular, or neither. All right, so we have these two lines here. 3y equals 5x plus 2, and we have 5y plus 3x equals 4. Now, essentially, what we're going to have to do is to put everything in the form of y equals mx plus c. So as you can see, it is already y equal mx plus c, but only fact that it's not really y, it's actually 3y. So what we do, for this equation on the left hand side, we divide everything by 3. The 3 cancel out here. So the 3 cancel out, leaving the y. So we have 5 over 3 x plus 2 over 3. So remember, it's y equals m x. So any number beside x is a gradient. So the gradient for the first line is 5 over 3. All right. So what we need to do now is to go over the other line and put it in the form of y equals mx plus c. Find the number beside the x, which will give us a gradient for the second line, then compare the two values. All right. And notice for the second line, the x is on the left hand side. All right. So what we need to do, we need to get rid of this x on the left hand side and put it on the, we need to get rid of this 3x on the left hand side so that it can go on the right hand side. So what we do is that we subtract 3x from both sides. All right, so 3x from 3x will give us 0, leaving the 5y. All right, and you notice we subtract 3x here. All right, so end up with 5y equals -3x plus 4. But still, it's not in the form of y equals mx plus c. So then no, we still have to divide everything by 5. And when we divide by 5, that goes. So we end up with -3 over 5 x plus 4 over 5. So the second gradient is -3 over 5. All right, now clearly these two gradients are not equal. All right, so since m1 is not equal to m2, then they are not what? Parallel. Let's try and multiply them. Now if we multiply them, well, a positive and a negative will give us a negative. Let me write it over here. So we have 5 over 3 multiplied by -3 over 5. So a positive and negative will give us a negative. The 5 cancel the 5, 3 cancel the 3. So everything is just 1. So you notice, when you multiply these gradients, you get -1. So the product of the gradients give you -1. So you notice, these two lines are perpendicular. And we use the symbol here to mean, to represent perpendicularity. All right, let's move on to the next question. All right. So we have this line here on the left, and we have this line here on the right. So as you can see, it's also in the form of y equals mx plus c. But it's not y, it's 2y. So we'll just divide everything by 2. All right. So the gradient here is actually 3/2. So this is what we're looking for, the coefficient of x, which is 3/2. Let's go over here. So you notice that we don't need this +8. So we need to get rid of this +8 by subtracting 8 on the left. And if we subtract on the left, we have to subtract on the right. So 8 from 8 will give us 0. So we end up with 4y equals 6x minus 8. It's still not in the form of y equals mx plus c. So we'll divide everything by 4. So we end up with y equals 3/2, x minus 2. Oh yeah, we reduce the 6/4 to give us 3/2. Now comparing the two gradients, we recognize that both of them are equal. So since the gradients are equal, then the two lines are parallel. All right, so let's look at this one down here. Let me just, this was an error. All right, so we have these two lines here. Let me rewrite it. Let me write it again. It's 5y. It just looks a bit choked down there. So. All right, let me use some fresh air. All right. Let me write that properly. All right, so we need to get this in the form of y equals mx plus c. So we don't need this +8 here. It's very similar to this one, not true? Come and think of it. I was looking at it. So we don't need this +8, so we need to get rid of the +8. And what we do is that we just subtract 8 from the left and 8 from the right. So this will give us 0. So we end up with 5y equals 6x subtract 8. Then we divide everything by 5 because we need it in the form of y equals mx plus c. So y is equal to 6 over 5x minus 8 over 5. So the gradient for the first line is 6 over 5. It's right here also. All right? And then now, the line on the right. So all we need to do is just divide everything by 5. And it turns out that M2, the second gradient, is 4 or 5. Now, obviously, they're not equal. 6 over 5 and 4 over 5. They're not equal, so they're not parallel. And when you multiply these two numbers here, they don't give you -1. Right, so they're not equal, and when you multiply these two numbers, you don't get -1. And you don't have to even multiply them because you realize that these two numbers are two positive numbers. And when you multiply two positive numbers, there's no way you're going to get a negative one. So, based on our observation, these two lines, they are neither parallel nor perpendicular. All right. So, let's move on to our next. Oh, so we have some more questions here. All right, so it says, state the equation of the straight line through 2, 3, parallel to 5x minus 2y minus 1 equals 0. All right, so what we have here, we have two lines. We have two lines. And on one of the lines, we have the point 2, 3. And the other line, what they do, they give you the equation of the other line. And the question wants us to find the equation of this line. That's basically what the question is asking us. So they give us two lines, right? One of the line have a point, and they give us the equation of the other line. So we want the equation of this line. Now, if you recall, finding equation of a line, we need two things. We need a point. So do we have a point? Yes, we have a point. Do we have a gradient? Well, we don't have it yet. We're gonna see if we can work it out. Now the key word here is parallel. The two lines are parallel. If the two lines are parallel, then both of them must have the same gradient. So all we need to do is to find the gradient of this line. All right? Now, clearly, this is nowhere in the form of y equals mx plus c. All right? So, we're going to get it in the form of y equals mx plus c. So, it looks, let me just rewrite what I have down here. So, because so even though it's written there, I just love to write again. I don't know why. So we have 5x minus 2y subtract 1 equals 0. All right. So we need to get this up here, so looking like this. All right. But the answer is actually already there for us, you know, but I want to work it out. So we don't need this 5x on the left hand side. So what we're going to subtract 5x on the left and on the right. All right, which is right here. All right. So you subtract 5x right here, so. And also you subtract it over on the right hand side. So what we're left with is negative 2y subtract 1 equal negative 5x. All right, which is this line here. But yet no, it's still not in the form of y equals mx plus c. I need to get rid of this what? This negative 1 by adding 1 to it. And see, I did it right here. So if I add 1 on the left, I have to add it on the right. When I do that, I get negative 2y. I'm skipping some steps here, guys. Negative 2y equals negative 5x plus 1. It's still not in the form. We have this negative 2, and we'll divide everything by what? Negative 2. All right, and then this would go away, because negative 2 divided by negative 2 is positive 1. When you divide 2 negative, you get a positive. So it's actually 5 over 2 x. Well, a positive and a negative here gives you a negative eventually. Oh, I made a mistake here, true. So this should have been a negative. Good thing I write it over now. So this would have been the answer. All right. Well, really and truly, all we need is a gradient. So the gradient of the line, ladies and gentlemen, is 5 over 2. So we have a point and we have a gradient. So we're going to find the equation of this line here. All right? All right, so I think I worked it out. Over here. Good. All right, so it's y, subtract the y value. Well, if the point is 2, 3, the y value is 3, divided by x minus 2, which is x value, and put that equal to the gradient. So we're going to cross multiply now. Let's multiply this one first with the y. So it's going to be 2 times y subtract 3 equals 5 times x subtract 2. Now 2 times y, we're going to use this distributive law here. 2 times y will give us 2y. 2 times 3 will give us negative 6. 5 times x will give us 5x. And 5 times negative 2 will give us negative 10. Then now we're going to add 6 on the left hand side and also on the right hand side. This will go away. And negative 10 plus 6 is negative 4. Then we divide everything by 2. That will cancel out. 24 goes 2. So this is our equation of the straight line. There should be an x right there. All right, so let me write it properly. Y is equal to 5 over 2x subtract 2. All right. Now let me just mention something to you here. This method of finding the equation of a line is just one of probably 2 or 3 other methods out there. All right. There are other methods. Sometimes, you know, every year I use other methods. Because last year I think I actually used this formula here. I use this formula, and then what I did, I replace m, because m represents gradient, and we have the x and the y value. All right, and all we need to do is just to find c. All right, so that's just another way of doing it. All right, so let's move on. Oh, we have more questions. So the coordinates of A and B are 2, 5, 6, 3 respectively. Calculate the gradient of AB. Pretty straightforward. We just use the formula there. y2 minus y1 over x2 minus x1. 3 subtract 5, which is negative 2. 6 subtract 2, which is 4. We get a gradient for equal to a half, negative a half. All right. So the interesting part of this question is part 2. is determine the gradient of the perpendicular bisector. Big word. All right. Okay. So perpendicular. We know that perpendicular means meet at right angle, not true? Bisector means to cut something in half. So technically, what they're saying that if you have a straight line, all right, a perpendicular bisector would mean a line that cuts directly through the midpoint. So this would have to be the midpoint. And this will cut at 90. All right. Now, you could have another line like this. All right. Let's say you have another line like this. You could have a perpendicular line like that. So this is a perpendicular line to this line, but it wouldn't be what we call a bisector line. All right. All right. So it says determine the gradient of the perpendicular bisector. So let me draw a line again. So we have that line here, AB. Now the gradient of AB is actually negative a half. And then we have another line that cuts it in the middle. So M1 is negative a half. So we need to find M2. Now we know that from the rule that the product of the gradient should equal to negative 1. Now if them don't tell us that it's perpendicular already, it means that if you multiply M1 negative a half times a number, it must give you negative 1 because they say it's perpendicular. All right, let me say it again. The gradient for the first line, when multiplied by another number, must give you negative 1. Have to give you negative 1. Why? Because they say perpendicular. So the question is, what number goes there? All right. So just by intuition, if one of the numbers is already negative, the other number in the question sign your block have to be positive, because a negative and a positive will give us a negative. All right. And by basic extinction, we know that, basic intuition, sorry. All right. I just say extinction a while ago, I have to be careful what I say right now because we have a wicked virus going around, So I don't want to say extinction. All right. Anyways, so just by intuition, we recognize that this has to be 2. Because a half times 2 gives us 1. All right. But what if you get some wicked fraction? Right? How do you work it out? What you do is just formula the equation. All right. So you could have negative a half. And you could have M2. And then what you could do, you could put everything equal negative 1. All right. What I would probably do is just to multiply everything by negative 1, just to get rid of this negative 1 here. Alright, so that would give us a half M2 equal 1. Alright, and then just by observation, you just multiply everything by 2, or you could just multiply everything by negative a half. So if I multiply everything by 2, 2 times a half will give us 1. So M2 will give us a half. So the gradient for the perpendicular bisector, ladies and gentlemen, would be a half. All right. All right. So I believe we're going to look at some past CXE questions. So these are structured questions. All right, and these are paper 2. Well, paper 2 structure, same thing, true. All right, guys. So let's look at this possible question here. Well, the first thing you need to recognize about this question here is that this line is falling to the left. It tells us that the gradient is negative. All right. And since they give us a graph, we can find M and we can find C easily. And we have a nice right angle triangle right here. So, all right. But you notice in this scale here, they didn't put these values here, true. All right, so that's a little level of difficulty here. But just by intuition, this will have to be 1, 2, 3, 4, 5. So this is 6, 7. So it says state the value of C. All right, and C we know is the y-intercept. All right, and just by observation, C is 7. So that's our 1 mark for part 1. Okay, part 2. Set the value of M. Now, we're going to ask right angle triangle right here. So we're going to use rise over run. So the rise, so let's count it. 0, 1, 2, 3, 4, 5, 6, 7. So our rise is 7. And 0, 1, 2. Our run is 2. So the gradient is 7 over 2. All right, but remember we said that the line is falling to the left. So that's going to be negative. Now you notice whenever you're using the formula now, the negative sign comes up naturally, mathematically. All right. All right, part 3 says determine the midpoint. We're going to use the midpoint formula. No, I'm not clear about this question saying that it's drawn to scale. But if it was drawn to scale, what we could have done is just to take a ruler and measure the length of AB. Let's say the length of AB is say 6 centimeters. Divided by 2, we get 3. And what we do, we put the ruler at A and we measure 3 and see where it lands on the line, and that will give us a midpoint. All right. Otherwise, we're going to have to find the points of A and B, and then use the formula to find the midpoint. So A, we know that right up here says 7. So it's 0, 7. All right. And B is right on here. That looks like 2 and 0. All right. So remember, anytime you're locating points on the axes, 1 is always 0. All right. Points on the y-axis, x is 0, and points on the x-axis, y is 0. So we're going to use the midpoint formula, and remember the midpoint formula is just the sum of the x values divided by 2 and the sum of the y values divided by 2. So x1 plus x2, so that's 0 plus 2 divided by 2. Then we have 7 plus 0 divided by 2. All right, and when you work out that, you're going to get 1 and 3.5 or 3.5. So that's our midpoint. All right, part B. So part B is talking about there's a point on a straight line, right? And they want us to show that that point, well, not really, well, they say it lies on the point, right? Now, if this point, negative 2k, lies on that line, there are certain conditions that will hold, all right? But to work this out, you see, we need to find the equation of the straight line, all right? So they're saying that there's a point, negative 2k, all right? So just for argument's sake, hypothetically, let us say the point is actually right here, all right? So we want to prove that, well, we want to find the value of k, knowing that this point is on the line. So we can use the equation and a point to work out the other value. Now the equation of the straight line is y equals mx. All right, now m is negative 7 over 2 plus c7. All right, notice the difference in this question here as in comparison to the other questions that we have been doing. All right, in the previous questions we were given points and we use those points to find the gradient, and then from the gradient we use a form to find the length, the midpoint, and equation. But because they give us a graph, it makes life a little bit easier for us. All right, so this is the equation of the straight line. So what we're going to do is that we're going to replace these values of the point in the equation. So y is k. So remember, this is the x value and this is the y value. So we replace y with k, and we're going to replace x with negative 2. Then we have plus 7. Now, let's go over here. So k, well, negative and negative will give you a positive. All right, 2 cancel 2. So we end up with 7 plus 7, which is 14. So k is equal to 14. So the point is actually negative 2 and 14. All right, part C. Let me just erase. All right, so to answer part C now, I think we're going to need a gradient, this thing here. All right, so part C, last part. Determine the coordinates of the point of intersection of the line y equals x minus 2 on the line shown above. All right, so what's really happening here is that there's another line. All right, just for argument's sake, is it? Let me. There's another line. hypothetically, let me just draw another line. All right? There's another line. And that line is called y equals x minus 2. And then you have another line, or the original line, which is this line here. And guess what now? These two lines, they collide, they clash. And they want us to work out the point of intersection. The point of intersection would have been right here. All right, so what we're gonna do is that we're gonna equate these two equations. All right, so they say that y is equal to x minus 2 and y is also equal to negative 7 over 2, x plus 7. It's like saying y equal mon, M-O-N, and y equal key. Now if y equal mon and y equal key, it means that m mon I go equal to what? Key. No, I didn't say monkey, no. Mon equal key. Alright? So if y mean one something and y mean the other thing, it means that two things on the right hand side must be equal. That's what basically I'm trying to say. And the same concept works for this. So if y is equal to this on the right and y is equal to this on the right, it means that these two things on the right must be equal. All right, so let's solve that. All right, so let me try to put things in perspective. So we have y equal negative 7 over 2x plus 7, right? That's the original line. And what's happening? We have another line called y equals x subtract 2. Alright, what I'm trying to say is that if y equal what we have on the right hand side and y is equal to what we have on the right hand side, it means that the two right hand side must be equal. So therefore, negative 7 over 2 x plus 7 are going to equal to x subtract 2. Whoops. Alright. Now, for me, I mean, this 2 down here is a distraction. So, for me, the best thing for me, I'm just going to multiply everything by 2. So, 2 times negative 7 over 2, this 2 and this 2 will cancel, leaving us negative 7x. Alright. 7 2s, 14. 2 times x, 2x. 2 times negative 2 is negative 4. So we need to find x. Alright? So what I'm going to do, I'm going to put, just to save space and time, I'm going to put the 2 over here, so the 2x over here, so it will be negative 2x. Likewise, I'm going to put the positive 14 over becomes negative 14. Alright, so you O and you O 9x, and that's going to be negative 18. So we're going to divide everything by -9. So let me see if I can erase this. All right, so sorry about this. I'm going upstairs here. Right, so we have -9x equals -80. So we'll divide everything by -9. So that cancels out. So x is equal to 2. Now, to find corresponding y values, you see? What we're going to do is we're going to choose one of these equations. Well, this is the simplest one. So we choose one of the equations. It seems as if we're doing something like a little simultaneous, not true? We choose the equation y equals x subtract 2. And we're going to substitute x equals 2 into that thing here. So we have y equals 2 subtract 2. So y is equal to 0. So the coordinates of where they intersect is x equals 2 and y is 0. Now we could have chosen this equation, the original equation for the, we didn't have to choose this one, but this one's simpler to work out, so let's use that one. Alright guys, so we're gonna end the session. So I'll see you guys around, alright? Alright, so we have a few more questions that we're going to look at in another video. And so thanks for watching and stay safe.